Hello everyone, thank you for being here today. I'm Jenny, the project producer of Japan Wind Energy 2020. Welcome to today's webinar, Deep Dive the Japan Wind Industry, which is hosted by Lead Associates in partnership with Water Forum Offshore Wind, Cytec Offshore Technologies, the Renewables Consulting Group. Before we get started, to better help you engage in the session, I have several little tips for you. First, audio. If you can hear me now, you are probably okay with the audio. But if you have any audio troubles, you can always switch to telephone mode. As you can see at the bottom of your control panel, there's a chat box option. We have already kept number inside the column. You can always check your email notification and call in with your own ID if there is anything wrong with the audio. Second, interactive Q&As. During the presentation, your microphone will be muted to avoid background noises. For questions directed to the presenters, there is a Q&A box. We will go through all the questions at the end of each presentation. Also, please do not put more questions or comments once the Q&A session starts, as we hope to create a greater atmosphere for the presenters to answer the pre-asked question, instead of being interrupted by constantly popped up messages. And our team at Leader Associates will help to answer some of your questions. Don't worry if we didn't respond to you. It means the question has been passed over to speakers for independent answer. All the audio recordings and slides will be shared with all of you by email before next Wednesday, and will be posted on Japan Wind Energy website as well as social media channels at the same time. Last few slides for my presentation, I want to tell you about my company and what we do. Lead Associates is an international clean energy invite organizer. We are dedicated to building relationships, building worldwide know-how, and creating new business opportunities for clients in the renewable energy industry. You can also see our strong record and a strong partnership around the world from the slide. Thank you for listening, my dear friends. Let's start with our first presenter and moderator of today, Mr. Garner, Managing Director of the Water Forum Offshore Wind.
Great. Thank you very much, Jeannie, for the very kind introduction. I hope you can hear me all right, everyone. And yeah, it's my great pleasure to be talking to you about offshore wind in Japan today. As Jeannie already said, my name is Gunnar Herzig, and I'm the Managing Director of the World Forum Offshore Wind. And it's my great pleasure to also introduce the other speakers of today's webinar, Mr. Akio Hasegawa, Director and General Manager at RCG's Tokyo office. And Mr. Hasegawa has a deep knowledge in civil engineering and project management development, developed over 20 years, working in different sectors such as renewable energy, power generation, and energy infrastructure. And we also have as a speaker, Mr. Luis Gonzalez Pinto Barrenechea, and he is the Chief Operations Officer of Cytec Offshore Technologies. And Mr. Gonzalez Pinto is also a highly experienced engineer. And interestingly, Cytec Offshore Technologies have only recently signed an agreement with the German energy company RWE for a floating offshore wind pilot project in northern Spain in the Basque Country. Yeah, so it's my pleasure to talk about unlocking Japan's offshore wind potential. And let me just start with a quick introduction of who we as the World Forum Wind are. We are a non-profit organization registered in Germany, and we are promoting offshore wind energy worldwide. And we have an international setup with offices in Hamburg and Singapore. And here you can see some of our international members from all parts of the offshore wind value chain, including also Japanese members such as JERA, and then also other utility companies from around the world, such as RWE from Germany, Northern Power from Canada, also some manufacturers such as Arca Solutions, installation firms, law firms, technology providers, financial advisors, and also other regional organizations promoting offshore wind in specific parts of the world. So with that, let's jump straight into the focus on Japan. So where are we with regards to offshore wind in Japan? On the right-hand side, you can see some of the important milestones that Japan has already achieved. And one very significant milestone was that in November 2018, the Japanese government passed the first regulatory framework for offshore wind. And that was actually an extremely important step, because now we have a regulatory framework, which is always the basis for all future developments. So that was absolutely crucial and a great achievement. And then following this very important first step, in July 2019, the Japanese government announced 11 offshore wind promoting areas. And 4 of those areas, which you can see on the map in the center of the slide, 4 of those areas have already achieved an advanced stage, and they are now being prepared for auctions. And those 4 sites are the Noshiro site, Yurihonyo, Koshi, and the Goto site. And interestingly, the Goto site is a floating offshore wind site. The other 3 ones are bottom fixed offshore wind. And in addition to those 4 sites, which are now being prepared for auctions, we also have an additional 7 sites, which require some further development and can then also be auctioned, but in a second step. So it's first those 4 sites that are being prepared for auctions. So if we now have a look at the kind of players who are already active in the Japanese offshore wind market, we can see 2 very interesting clusters of joint ventures, of project partnerships. One cluster is actually a combination of Japanese players together with international players. And we've seen several announcements, very high profile announcements. For example, the German energy company E.ON, which is now part of the RWE group, already last year announced a joint venture with the Japanese company Kyuden Mirai Energy to develop offshore wind projects in Japan. And actually only this week, RWE, which now takes over this partnership with Kyuden Mirai, RWE, together with the Japanese partner, already announced that a joint feasibility study for the offshore wind project off the coast of Yurihonyo in the Akita prefecture is planned, so a very concrete step already. We've also seen the announcement by the Canadian energy company Northern Power, together with the Japanese company Shizen Energy, who are also going to jointly develop offshore wind projects in Japan. And then we also had the high-profile announcement by the offshore wind market leader from Denmark, Ørsted, together with the Japanese utility company TEPCO, who are now preparing the Koshi wind site in order to participate in the auction. And in addition to those international joint ventures, we also have some Japanese joint ventures. For example, JERA, the Japanese utility company, together with Shimizu, have agreed on a memorandum of understanding to collaborate on offshore wind projects in Japan. And also the Japanese trading house Marubeni, together with a large number of Japanese companies, have also already announced to very actively develop 2 sites actually in the Akita prefecture. And we will now zoom in to more detail into this Marubeni project, because that is the most advanced project at this stage in Japan. And on the left-hand side, you can see some of the project details. So as I mentioned, here we're talking about 100 megawatts of capacity in total, split across 2 different projects. It's the Noshiro port and the Akita port project. And combined, they have a capacity of 140 megawatts. And they're using bottom fixed foundations. And commercial operation is scheduled for 2021 over a duration of 20 years. And the electricity is then planned to be sold to Tohoku Electric Power Company from Japan. And on the right-hand side of the slide, you can see some of the project partners. And here it's really interesting to see the large number of Japanese companies that are already involved, including construction companies such as Obayashi, for example, other electric power companies such as Kansai or Chubo, and also an oil company, for example, Kiowa Oil. So very interesting to see this very broad setup and broad interest from the Japanese industry to participate in this offshore wind project. And we can also see very prominent banks who are participating and who are lending money to the project. So the debt providers, we have the famous Japanese banks, MUFG Bank, Mitsuo Bank, and Sumitomo Mitsui Banking Corporation. And interestingly, those banks are already very active in lending to other global offshore wind projects, especially in Europe. So they are already very familiar with providing debt financing to offshore wind projects, and therefore they can now very elegantly transfer all that knowledge to the Japanese market and don't need to start from scratch. Then one interesting observation on the costs. Project costs for this Marubeni project are being stated with 100 billion Japanese yen, which is roughly 840 million euros. And if we divide the 100 billion by the number of megawatts, 140 for this project, we come up with a cost per megawatt of roughly 6 million euros per megawatt. And that's, of course, considerably higher than the current offshore wind price for bottom fixed in Europe. But I think it's perfectly understandable and completely normal that for any new market, initially costs are a bit higher, but then the very clear and perfect observation would be that costs come down over time. So I think that's perfectly normal in this case, that we have slightly higher costs in the beginning. And if we now touch a bit on the very interesting topic of floating offshore wind in Japan, because given Japan's location surrounded by deep waters, floating offshore wind has always an ideal floating foundation. And in addition to those demonstration projects, we have now also seen announcements for larger scale projects, which you can see on the right-hand side. Very early already, SciTech mentioned the cooperation with Univergy for Japanese floating offshore wind projects, and I'm sure Luis will tell you more about that in his presentation. We've also seen the MOU between the French designer Ideol and the Japanese Taisei Corporation to develop floating offshore wind projects. Similarly, Principal Power, another floating offshore wind technology provider, only this week actually brought in the company Tokyo Gas as an equity stakeholder, also to strengthen Principal Power's position in the Japanese market. And also the French technology provider Naval Energies, together with the Japanese company Hitachi Zosen, have also announced a cooperation for floating offshore wind. So we can really see this momentum of several very prominent and renowned international companies partnering up with big Japanese companies in order to push for more floating offshore wind in Japan. Yeah, so what conclusions for the Japanese offshore wind market? So I think we can clearly say that Japan is definitely one of the world's most promising and dynamic new offshore wind markets, in addition to the existing markets we've seen so far. Definitely for bottom fixed offshore wind, but probably especially for floating offshore wind, given Japan's location with deep waters and the experience Japan has already made with all the demonstration projects and research into floating offshore wind. So I think particularly well positioned for floating offshore wind. With regards to the supply chain, I think it's also fair to say that Japan's very strong industrial backbone is very helpful to create a very strong local Japanese offshore wind supply chain, given all the companies who are already involved, as we've seen in the Marubeni project. I think it's very reasonable to say that with all its industrial power, Japan will be easily in the position to set up a very competent and world-class supply chain domestically within Japan for their offshore wind developments. In addition to the supply chain, we've also seen that on the financing side, Japanese banks are already very involved in offshore wind financing in European countries, and they can now take all those lessons learned to Japan and make sure that they can also lend to Japanese offshore wind projects. So I think in conclusion, we can definitely say that the 2020s will definitely bring the breakthrough for offshore wind in Japan. And I think it's only a matter of time when we will really see the first large-scale projects installed and up and running in Japan. But I think everyone can be very confident that that is going to happen soon. Yes, so now I'm very happy to answer some questions, and I've received a couple of questions from the audience. Let me start with the first one. So the first one was, what are the perspectives and challenges for offshore wind in Japan? And I think here it's fair to say, yeah, that everything now depends on the results of the auctions. So we will, as we said, the government identified those 4 sites for auctions, and soon those auctions will take place. And then the interesting question will be who's going to participate in these auctions, what will be the exact design of those auctions, and especially what will be the results of the auction. And I think that will then give us a better understanding of where we are. Yes, so with regards to the first question, indeed, everything is going to depend on the auction results. Then the second question, yeah, what's the current development plan and incentive policies for offshore wind in Japan? And I think, again, that is very much related to the question of auctions. So the auctions will work in a very sensible way, which is already experienced in many countries, where companies submit bids for price per kilowatt hour, so Japanese yen per kilowatt hour. And then that is usually the most important criterion. You can add other aspects as well, but then usually it's the case the lowest bidder wins the project and can go ahead with the project. And that is, I think, very established and very successful measure of awarding sites to the market. And therefore, I think, that is very clear to the market. And now the interesting question is going to be, what kind of bids will we see? Are we going to see very aggressive bids, as we've seen in some European markets with similar auctions, for example, in Germany or the Netherlands? Or will it be slightly differently? But that is definitely going to be very interesting to see the kind of auction results. And then the next question is how to prevent, very interesting question, how to prevent Japan from stepping in the same governmental approval mistakes Germany did in the early offshore wind years. And I think it's absolutely correct to say that indeed in its early offshore wind years, Germany did some mistakes with regards to the regulation for the offshore grid connection, because there were some cases where you had the offshore wind farm fully installed and ready to produce electricity, but no offshore grid connection in place because the grid operator had not yet completed the grid connection. And that's, of course, an unlucky situation where you are ready with your project, but you cannot export your electricity to shore. And therefore, I think that's always very important for governments to make sure both steps are aligned. So the build out of offshore wind farms, but also the build out of the offshore grid connection. So that, I think, is something that is always recommended. And then the last question is, what is the future for offshore wind in Japan? And I think here, it's indeed going to be very interesting what the auction results are going to be. But then I'm sure the future for Japan is going to be very promising. And it's surely going to be one of the most interesting and dynamic offshore wind markets. And we already see so much global interest from players around the world in the Japanese market. And therefore, I think the future for offshore wind in Japan is indeed looking very bright. And I think, that was it from my side. And now it's my pleasure to hand over to Mr. Akio Hasegawa. Thank you very much.
So again, this is Akio Hasegawa from RC Japan, from Tokyo. To introduce myself, I have an engineering background, a civil engineer, a lot of experience in energy sector. Today, I will present the title is Fixed Bottom versus Floating Wind. Mainly we focus on developing side. So first, RCG, our company is the company to deliver integrated market research and management consultant and technical advisory mainly. For the last 1 year, we are very deeply involved in providing development and technical support in Japan. In this presentation, I would like to share some of findings and also consideration we obtained through our experience, and I hope it will be very useful for you. Okay. So this slide, first slide, this describes the current status of Japan, current status of Japan development. Japan has the 7th longest coastline in the world and has a large offshore wind potential. There are some existing studies looking into the technical potential of offshore wind, shows a significant opportunity. Roughly 100 gigawatt for fixed foundation and also 200 gigawatt for floating. But these numbers are likely to be larger than the reality due to the other constraints, such as grid constraint. But still, it still has a very significant opportunity. In 2015, METI unveiled an energy plan under which renewable will account for 20 to 24% of the country's power mix by 2030, with 1.7% of wind. In order to achieve this 1.7% from onshore and offshore wind, JWE, Japanese wind organization, they estimated a total of 10 gigawatt, 6 gigawatt from fixed foundation, and 4 gigawatt from floating, and also by 2030. Post 2030, they also predict ambitious plans to increase offshore wind capacity to 37 gigawatt, which is 19 gigawatt from fixed foundation, and also 18 gigawatt from floating by 2050. This chart shows our RCG estimation. So roughly by 2030, we predict roughly 8 gigawatt offshore wind will be introduced. There are two frameworks to utilize sea areas, which are port areas here, and also the general sea, common sea area. But areas are limited to territorial sea areas, which is 12 Nordic mile from the coast. And also there is no framework in the EZ zone. And next, this slide shows offshore wind project under EIA process currently. Very significant amount of EIAs were initiated in the promotion areas mainly, like Akita, Aomori, Nagasaki especially. And currently 550 megawatt for port project, this blue one, and also 12.9 gigawatt for general sea project. This is mainly fixed bottom foundation project under EIA process. But please remind, some of projects are overlapped. For example, Akita and Aomori, some of projects are overlapped in the same region. So actual amount of capacity will be less. And this chart shows what Japan has done to promote offshore wind. First, policy and also promotion zone. The first wave around 2016 came, which is a port area project. Mainly, the government amended port law, enable us to utilize port area for offshore wind in 2016. And also second wave, mainly for general sea area project, happened in 2019. Marine renewable law was established, and also this red line shows the number of EIA. So rapidly, many projects initiated EIA in 2019. And also technical guidelines side, some of key guidelines, technical guidelines were established by the government. Unified explanation technical, I will mention this in the latest slide. And also for the technical demonstration side, the government, NEDO, initiated demonstration project. Actually, it's very old history. In 2013, they started some demonstration project in Fukushima and also Nagasaki and Kitakyushu. So for the introduction of the floating offshore, verification of technology through this demonstration project, and also some technical standards also established here for floating as well. This is a development framework and also some consideration we have. This figure shows current offshore wind development framework. So first, on the grid side, need to secure grid interconnection agreement, and then auction process start, and then some of permissions required, like METI construction permit, and EIA, and other local permissions. It is considered this current development scheme framework may be used for floating as well, but there are additional consideration. Let's move to the next slide to explain. So this is a kind of very the additional consideration for floating in addition to current key consideration for the fixed foundation. For example, EIA, probably accumulated impact together with existing onshore and also offshore projects might be necessary to consider. And officially, this is very important. Also authorization, conformity with Japanese design regulation, and also third-party certification might be necessary, and the very rigorous reviewing is required. And also grid, very heavy constraint. Extreme climate, higher seismicity, and infrastructure, it still need to expand facilities. I will take up some of key issues in the next slide. First, this is officially, right now, the ongoing project located in the fishing light zone. In this map, red zone showing fishing light zone. Normally, this is located along the Japan Sea coast. So the ongoing projects are located in this area or very close to this area. But regarding floating, assuming they are sitting far from the sea coast, probably out of this fishing light zone, but also outside the fishing light zone, the fishing activity is quite very aggressive. This chart, this figure shows some of major Japanese fishing ground, Sanrik and also Japan Sea side and also Kyushu side. It's very good to know there are two major current, the warm current from south, also cold current from north. So here likely to be a good fishing ground since both current collide with together. And also this red circle shows the top 10 fishing catch in each fishing port. So obviously Pacific Ocean and East Coast has more fishing port with a higher catch. And this slide shows METI construction labeling framework. First, developer has to submit construction plan. This is a design document mainly. And next, prior to the reviewing, having a reviewing by the METI, it is necessary to get certification. It's a wind farm certification by the third party. And then METI and also academic experts, mainly professors, they will have a very rigorous technical reviewing. And also regulation, as I explained, major law, electrical business law, and also Port Act. These two are very major law, governing law. So this year, the government issued, by integrating these two laws, they issued unified explanation of technical standards for offshore wind facilities. So this is one of important technical guidelines to comply with. Next, grid. This chart shows how much capacity, how much project applied. The blue one showing capacity within 30 days curtailment, and also green, this is a project in operation. Purple, this is a grid connection agreement already done. And the orange, this is a project grid study applied. So in Hokkaido and Tohoku and Kyushu, you can see such a big amount of exceed the capacity with 30 days curtailment project applied. So this is Hokkaido and Tohoku and Kyushu is very challenging grid constraint. But the government and Okuto and the utilities, they are doing major efforts to expand capacity. So first, this cross-regional interconnection line between Hokkaido and mainland, and also between Tohoku area and Tokyo, are now being planned. And also the large-scale strengthening of grid line in Tohoku area to accept 3.9 gigawatt is being carried out. And also in Kanto area, Chiba region, TEPCO is considering to introduce non-farm connection methodology. We hope, we expect this kind of effort can expand the capacity for renewable. And this is a natural condition, earthquake. Generally, this is the distribution map of epicenters, and also this is a hazard map and showing the probability for the next 30 years with earthquake intensity larger than 6. Due to this is a quite tectonic theory. So we have, Japan has a fault plate, and also there is a tectonic line, subduction zone here, Nankai Trough, and also Japan Trench and the Chishima Trench. So this area are likely to have a bigger earthquake, like site magnitude is likely to be magnitude 8 and magnitude 9, with 100 to 200 years return period along Nankai Trough, and also 300 to 400 years return period along Japan Trench and the Chishima Trench. And also hazard map shows higher possibility along this area. And this is current effort to expand the infrastructure. Government decided to upgrade the North Shore Port and the Akita Port for Akita region for Round 1, and also Kashima Port for Choshi Round 1, and also Kitakyushu Port for Round 1 in Nagasaki. They will upgrade the port as a construction or O&M port to cover the early round, probably round 1 or round 2 as well. And it is expected to expand further construction and O&M ports for future offshore wind project as well. This is conclusion. Japan has a quite large offshore wind potential, and the policy, design, standards, infrastructure have been prepared. The first wave port project came in 2016, and the second wave for mainly fixed foundation in general sea area came in 2019 or this year, 2020. And the third wave, expecting for offshore floating to come soon. And also some of issues and considerations, Japan-specific issues, such as fishery and earthquakes and designing standards, grid capacity constraints are necessary to be considered. This is 4 questions I received in advance. I think I already included answers for this question in my slide, but just run through very quickly. Any local content regulation for sure. As I explained right now, Japanese designing regulation already issued to comply with. Current offshore wind farm development plan and incentive plan. Current, as I showed, quite a significant amount of projects underway. Incentive, this is a feed-on tariff, but auction was introduced, so price will be decided by auction, but period of time, 20 years will be secured. And how big? It's a nearshore wind market in Japan. So maybe I have to include several answers. So first, potential, I explained potential, like 100 gigawatt, technically 100 gigawatt for nearshore project, fixed foundation, but likely to be less than this number, since we have to consider grid constraint, but for round one, quite very aggressive. A lot of projects under EIA. Which are the main challenges for this is exactly what I explained in the second half. So seismic and also fishery, grid constraint. This is a specific consideration to in Japan. Thank you so much.
Thanks a lot for sharing, Mr. Akio. Welcome to our next presenter, Mr. Luis from SADI.
Yes, konnichiwa. Good afternoon for those who are in Asia, and good morning for those in Europe. So very briefly, I will first of all just introduce our company, a little bit what we do. I will go quickly to show some trends on the global offshore wind market, which we think is quite positive for floating. And then finally, I will just go to the focus on the topic, which is the Japan floating wind readiness. And I will get from a little bit as we see it in our projects. So first of all, we are part of SciTech Group, which is an infrastructure engineering company. Coming from that knowledge, we started as an R&D project to try to use the knowledge of civil engineering and apply it to floating wind. And we started to work in a new floating technology, which is called SAF, which I will go very quickly just in a moment. And in 2016, we created a new company. Currently, we are 22 people. We have only one subsidiary, which is in Japan, which is SciTech Offshore Japan, KK. And we are growing quite a lot. And I will just go a little bit to show you a little bit about our technology. We have this technology which can be summarized in a pre-stressed catamaran shape platform with single point mooring. So basically, we precast the parts in concrete and we assemble them. We use concrete mainly for 3 reasons. First of all, we think it's much more cost efficient than steel. Secondly, it withstand better the harsh marine conditions. And finally, it allows us to increase the local content. But as I'm going to remark later on, is quite important. Finally, we have this single point mooring, which allows the platforms to rotate around one point, and which enables us to reduce also the cost of the mooring system. So as we said, we think in local content. This is as a very old image. Obviously, there will be changes because this is from 2017, and it was for a manufacturing facility in the north of France. And as you can see, we precast the parts of the floater in concrete, and then we get into assembly positions until then, after all, we pre-commission the turbine and we produce with the launching. This way is a ship lift, but it could be also a semi-submersible barge or other means. We've been doing quite a lot of work to get where we are now. A lot of hours of engineering, lots of tank testing to understand our phenomena. And we are working in 2 demonstrators and also in other commercial projects. demonstrators. Now we are going to commission BlueSAF, which is a reduced scale demonstrator funded by the European Union. Unfortunately, due to COVID, we have some delay, but we are about to commission it. You can see the picture of the towing at the time. As Gunnar has remarked, we have closed the funding for DemoSAT, and we are collaborating with RWE, which is we're quite happy with that, and not only because they support us financially, but also in technical way, and we are quite really. I always say thank you to them, because we are doing a great job together. We are all over the world, as said. I think this floating wind is about globalizing offshore wind, so we must have a global action. And as said, we are our subsidiary in Japan, which is the first subsidiary we created, and is one of the key markets we want to target. Just some small trends. I will go really quickly. First of all, we see that turbines are getting much bigger. And we see it with the Haliade-X from GE at the time, which is already installed in Rotterdam, with the new announcement by Siemens Gamesa of the new 14, 15 megawatt turbine. We'll see what Mitsubishi Heavy Industries and Vestas release soon, but it all looks like that turbines are going to be bigger. And in the case of Japan, given the reduced speeds compared to the North Sea or to Taiwan, probably we're going to see bigger rotors in those seas, even though the typhoons are there. Also, we see that the local content is a major concern all over the world, in the US, in Scotland, in Taiwan. It's something we are seeing every day, and that's something interesting. We think that bigger wind turbines are better for floating wind, as we see most of the floaters don't increase in the same rate, in the same size as the rotor do, and when you see the means that you are going to require for bottom fixed installation, they increase significantly. So we are quite happy. This is the stadium from Bilbao, our local team, and this is a 12 megawatt wind turbine to see a little bit things in perspective. Also, we are seeing that there is a higher pressure for developers. They have to reduce the cost of energy. The oil and gas players are coming, so there are significant movements to gain volume in order to bring costs down, and also to enter new markets. And new markets, most of them mean floating wind markets, as most of the waters, as you all know, most of the waters are in deep water. So new market globalizing offshore wind means more floating, which is good for us. And as I said, we are seeing on the news more and more oil and gas players are coming, that they have a powerful balance sheets. So this increased competition. And we think that to compete is not only about being bigger, but also about doing things differently, which enables opportunities for new technologies and innovation in all fields. We see that, as said, offshore wind is not anymore just only something of the North Sea. The US is coming to the party. Taiwan is massive. We see also China developing, and Japan is just starting now. So global is good for floating too. Also, we see that the wind farms are going to get bigger, and we see many reasons for that. Bigger wind turbines, you have to diversify your risk. And also we see that demand is going to increase due to electrification and our new uses like hydrogen generation that are going to make that will be more reasonable to go to bigger wind farms, and as a consequence, bigger opportunity for floating. As we need to increase the size of the wind farms, we are going to go to deeper waters almost instantly. And also we're really excited for floating because we see massive opportunity to bring costs down. We are all using immense safety factors in our demonstrators. We also see that the turbine increase of power is going to reduce it. We see that new materials and new technologies we are all developing, and also obviously scale. This is also about the scale, and if we do 2 gigawatts is going to be much cost efficient than doing 2 megawatts. That's pretty obvious. And I think this is quite exciting times to come. And I'm just going to go to Japanese floating offshore wind. And I'm going to analyze it in 5 factors. So the clear legislation, the grid access, floating technology, including certification, which is a very typical question in most of Japanese discussions, the required infrastructure, the supply chain, and then just a final conclusion. I will go on there. So I think now we've got a clear legislation. I'm not going to go in so much detail as Hasegawa-san has gone. I think he done a very good presentation. So I'm going to focus on some small points. First thing is that Japan has taken a different approach to Europe, much more looking for consensus, making sure that projects are going to move forward from the very beginning, trying to involve much more local stakeholders from the very beginning. With the determination of the promotion areas is much more work with local stakeholders, which is very critical. Nowadays, the promotion areas, I'm not going to go into details with all of them, as most of them are bottom fixed. But I'm quite positive in the future. And what we see here is that legislation states very clearly that you must take into account local stakeholders. You can have a very good project, but you must make a positive impact to the local stakeholders if you want to make it more forward. We see that now there is a clear auction system, initially with the 36 yen per kilowatt hour, which is expected to reduce, I will guess, quicker in bottom fix at the moment, because there is not much floating developing yet. There are lots of things moving, but on the fair auction is expected to be reduced, probably given some of the concerns, as we said, that Japan has in terms of grid, in terms of harsh environment. The auction results are not going to be so low as they are currently being in Europe or in the US. We see that now is 50-50, 50% price, 50% of soft points. But it seems that as experience grows, probably we are going to put more weight also in the price, and there will be less than 50-50 and move to 60-40 and then move forward. As I said, in these soft points, experience is required. That's why we are seeing that there is a significant opportunity to work with overseas and Japanese companies working together to implement that experience shown in Europe and in other parts in Asia and implement it in Japan. I think another good point is that it's been a good experience with the councils, with the local fishermen in round 1, which is quite positive. Which one of the main concerns everybody had was managing the fisheries, and the FX experience in round 1 has been quite positive. So we are not 100%, maybe 95% of things clear, and as happens everywhere in Europe or in the US, there will be some tweaking after in the regulations, but we have, I think, a clear path for developing projects. As said, the grid access in Japan is quite complex, and there is obviously some problems with the grid connectivity, although they are still working in implementing more grids. There is the unbundling has already started for the EPCOs, but somehow they are still in control, and now it has to be a little bit more clarified how the connect and manage process is going to be defined. But in any case, we still have this curtailment agreed of up to 720 hours per year, and a little bit more in case of emergency. So it's still very important if you can involve an EPCO in your process to make sure that you are able to reduce as much as you can the curtailment. that is something that must be taken into account for producing, going to the action, and obviously increase the cost of the energy. As said, some of the European players are already joining forces with EPCOs, as Ørsted with TEPCO or JWE with QD Mirai, as Gunnar remarked. For the moment, these are partnerships only for bottom fix, but I'm pretty sure that all developers, European developers, are already in discussions for floating wind projects. So floating wind is gaining traction all over the world. We see a great job done by many players with Equinor or Principal Power. We see that the French action next year in France of the first commercial floating commercial wind farm is happening, which is going to be a major milestone, I think. And I think it's quite positive signal for all. What happens in Japan? I think in Japan, I think the bad things maybe probably is that Fukushima forward project did not give the expected results, and there is a quite pessimistic view in Japan after Fukushima forward, mainly given the cost and the means that were required at that moment. So there, I think there is quite openness to introduce overseas technologies to compete. I think also we have a little bit conservative approach to design, and it would be great if we could better clarify the requirements, working with academia, harmonization with more international standards, and I think it's something we are all working on. All floating technology developers, we are working on that because it's a major challenge. I think this a quite conservative approach, just to say when floating happens all over the world, we are going to try to implement it in Japan. There is not all people, but some approach like this. I think that is not very good, because that could create the creation of other hubs in other Asian countries, which would reduce the economic opportunity for Japan. And also there is a little bit of higher cost in manufacturing in Japan as a general rule of thumb. So some floated technologies are thinking of importing from overseas or Indonesia or other places to manufacture the floaters there. We think that's not the right approach. In our approach, we think that local content is important. We think we want to manufacture in Japan. And if the Japanese society is providing some areas to produce electricity, we must give some economic opportunity back. But this requires not only just reproducing your technology and bringing it to Japan. This requires Japanizing your technology, both in terms of for the harsh environment, from the standards, but also for construction techniques, available materials. So it's quite an interesting challenge, but we are quite happy with the way we are moving it forward. But as I said, I think, but it keeps moving, because I think most of the best wind resources is in deep waters or in the north, but in the north there is quite problems with connection. So I think Japan must be floating, given the places where you can find the resource, which is in most of the wind resources in deep waters or in places with very, very limited connection. And also, I think when we see the harsh environment of Japan, obviously it's quite harsh, and we are having typhoons, we are having earthquakes, we're having soil liquefactions, we're having tsunamis. But this is not a major problem for floating wind. I think floating wind is much less affected than bottom fix on this. I've have the luck to have a look of the foundations for bottom fix in Japan, and compare it to the foundations in Europe, and the difference is quite massive in terms of the size of the structures and what they have to withstand. Because if we have if floating wind has a soil liquefaction, at the end of the day you lose an anchor. But if you have soil liquefaction in a bottom fixed foundation, that's a much bigger problem. The same happens with tsunamis or typhoons. at the end, a tsunami is a very, 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 very big tide for floating, and you have to take it into account for your mooring system, but it's not the same problem you will have with bottom fixed. Also, we see some special vessels, elevated vessels limitations given the cabotage laws in Japan. And I think that that's going to be a challenge, particularly as turbines are getting bigger and bigger. And probably the first projects are going to be installed with overseas vessels with special instructions and obtained by the government. But I think that's going to be a big challenge for bottom fixed. But as we say, we have, and there are enough tugboats in Japan, which can do most of the work for installation of floating wind. So we think that's quite positive there. I think the bottleneck, and then I've got a question about that. The bottleneck for floating wind are the ports, and basically because ports are, but it's not only for floating wind, it's also for offshore wind. I think that the timeline for ports is much longer than the timeline for offshore wind. 70% of floating wind is the same as bottom fixed, but obviously you need a significant capabilities of your port. We are discussing on between 20 and 60 hectares from this study of France Énergie Éolienne, and this is one big challenge. But I think the way to move this challenge and to make it happen, and without entering too much detail on the requirements, because they're quite dependent on the technology, quite dependent on the project, and this has to be analyzed case by case. But we need to have a proper project pipeline to really analyze what is required with the ports and collaborate with the local administration and with the national government to make sure that the ports are available for the massive opportunity that offshore wind is in Japan. Finally, the supply chain. I think almost all trade houses in Japan have taken part in offshore wind and transmission projects in Europe, so they know the business. I think that's a massive opportunity. I think that having companies which are solid financial capacity and experience in offshore wind it makes a significant difference compared to other markets. I think Japanese companies are operating all over the world, and they know how to do international business. They are used to create joint ventures, reach agreements in any place in the world, so they are quite well prepared. As Gunnar said, their industry is capable of almost anything. And I think supply chain happens when demand is there. So this is just a matter of, I think, of taking this opportunity for floating. And if we take this opportunity for floating, the demand is going to be there. If you wait too much, probably you will have problems because some other countries will create their hubs and they will try to export, and they will reduce your economic impact. So finally, you are never completely ready. I'm a rugby fan, so I always loved the cherry blossoms. And for me, this is a quite the story, and I think that big rewards require big efforts. I don't think these guys were ready before the World Cup to do what they did. No, you are never ready, but you have to believe in your opportunities and be yourself. You are able to capture know-how, not try to reproduce the North Sea model. Create your model based on your capabilities. You have a big industry, you have financial capabilities, you have very good at innovation, you have other business collateral. So go for floating and be yourself, and maybe you could do great things as these guys here. So arigatou gozaimasu. Thank you very much for your attention, and I will just go for the questions and answers. And as said, first question, I think I've just go through a little bit, which is the biggest bottleneck for floating offshore wind projects from my technical view, I think is the port infrastructure. I think this is the biggest bottleneck. I think at the end of the day, all offshore wind needs a significant surface. We are going to use very big wind turbines, so we are going to have some soil requirements there. But as said, I think for me it's just a matter of setting a clear pipeline, probably much more ambitious than the figures we have seen in previous presentations. But and if we set that pipeline, I won't see a problem of the possibility of implementing that in Japanese projects. So are we going to class clay pre-approval concept? And if yes, what challenge do you see ahead? Yeah, we are in the process of Japanizing our technology. We are working on how to adapt it to Class NK certification, but much more than that. We want to adapt it to be able to manufacture, and we are working with Japanese construction companies to adapt it to the materials available in Japan. You don't have the same concrete available in Europe than in Japan. You don't have the same construction techniques. You can benefit from other things. So it's quite interesting challenge as we are moving forward. So then, but will floating technology maintain at the feed-in tariff regime in the next years? Well, I cannot predict the future, unfortunately, but I would say for some time, yes. I think that the first project, as Goto project, has already the 36 Japanese yen capped there and established, and they are mainly going to the action just to be based on the other 50%. And there is another framework. There is a framework for floating wind and a framework for bottom fix. But I think in the future that would move. I cannot predict the future, but I think that probably the next 2-3 years, I don't expect significant movements on that feed-in tariff. But then after that, I think competition will be fierce, as it's all over the world. I think given that some of the reasons, given the resource, the wind resource, given the curtailment of the grid and other features, we are not going to be in the same range as what we are going to see in Europe for the moment. But I think that would move in the future, and in the next 10 years, I think that is going to be a convergence to similar prices, taking into account a little bit different in cost of manufacturing. And finally, where are the biggest risks in terms of floating technology? Well, it's difficult to say to a floating technology developer, which are your biggest fears. And because obviously, well, in any project, we are facing continuous risk for anything, because these are complex projects, of course. So which are the biggest risks? I think the biggest risk, I will go same with the bottleneck. I think biggest risk is depending on what you are considering. I think biggest risk is the lack of clarity in the pipeline of projects, which complicates a little bit the infrastructure. I think the technology development of floating competitive technologies is there and is moving forward, and we are seeing the numbers every day. And I predict that the numbers for French tender next year are going to be really, really, really aggressive. So the technology is going to be there. But I think biggest risk is not having the infrastructure ready to move projects quickly and achieve the production. But I think it's more about being a little bit more aggressive in terms of the pipeline of projects and producing more clarity. As said, I think Japan is moving in more a consensual way than Europe, which is maybe difficult for us because we want to move quicker than that. But maybe in the long run, it's going to be better because it's going to be, let's say, smoother than what things that happen in other countries. So thank you very much for attending, and thank you especially for Leader Associates for inviting me to give this key speak note. So thank you very much.
Yes, thank you so much. Thank you for sharing, Mr. Luis. And thanks for the other speakers, Mr. Garner from Waterfront Offshore Wind, Mr. Aku from the Renewables Consulting Group, Mr. Luis from SciTech Offshore Wind Technologies, and all the audience staying with us for this Japan Wind Energy webinar. At last, I would like to remind you of the conference Japan Wind Energy 2020 on 28-29 October in Tokyo, Japan. The second Japan Wind Energy 2020 is a premier information change and business networking platform between public and provider stakeholders in the country wind value chain. At the end, you don't worry, PPT slides and the recordings will be shared you by email before next Wednesday. Thank you again for your participation and hope everyone can keep healthy and safe under the influence of the COVID-19. Hope you have a nice weekend. See you next time. Bye.